Okay, in the next few examples, we don't have quadratic expressions or trinomials that are already perfect squares, but we're going to force them to be perfect square trinomials so that we can factor them into a perfect square binomial. So this page is just kind of a visual of how we can do that. So what we're basically starting with is x squared plus bx. The area of this square is x squared. That's where the x squared comes from. And the area of this rectangle here is b times x. So that's where the x squared plus the bx comes from. So what they do is they take this b times x rectangle and they split it in two, and they put it half of it up on top of the square and keep the other half down at the side. And what they're going to do is they are going to fill in this space here to make this a perfect square. And the area of this square that they're adding in there is b over 2 squared. So that's where the b over 2 squared comes from. And this square, the length of this side is x plus b over 2. Length of this side is x plus b over 2. So the area of that square is x plus b over 2, the quantity squared. So what we're going to do is take that b term and take half of it and square it, and that's what we're going to add to both sides when we are solving these by completing the square. So we're going to take a look at a couple of actual examples here, and that's just kind of a visual. Now, this particular method I would only use when a is 1 and b is an even number. Okay? If that's not the case, I would not use completing the square as a method to solve these quadratic equations. I wouldn't. There's another method we'll talk about tomorrow that will help us do just that. But with these cases, completing the square works pretty slick if a is 1 and b is even. If that's not the case, I would not use completing the square. Now, in this case, and again, first choice, I would always use factoring if possible. The only problem is, in this example A, factoring is not a possibility. There are no factors of 2 that add up to -4. It just doesn't work. Because the two numbers that would go in the parentheses, they would multiply to 2 and add up to -4, while the only two numbers that multiply to 2 are 1 and 2, and there's no way we can manipulate those to get -4. So this one is not factorable. So what we're going to do then is complete this square and solve this by completing the square, because a is 1 and b is even. So what we're going to do then, first thing you do is clear the constant. We want to move this 2 to the other side by subtracting it. So x squared minus 4x is going to be equal to -2. So we just subtracted that 2 to get it to the other side. Now, next we're going to add the same thing to both sides. Now, we're going to take this b term, this 4, we're going to take half of it. Half of 4 is 2, and then we're going to square that. So 2 squared is 4. So we're going to add 4 to both sides. So when we do that, we end up with 2 on the right side. And then we're going to factor that left side. What factors of 4 add up to negative 4? Well, negative 2 and negative 2. So we'd end up with x minus 2, or x minus 2 squared, which is why we added the 4 to begin with. Because if you do this correctly, this trinomial over here will always factor to some binomial squared. Okay? So in this case, we are squaring some number to get 2, so that number is either equal to plus or minus the square root of 2. And again, that square root doesn't come out evenly, so we're going to leave it as the square root of 2. And to get the x by itself, we add 2 to both sides. And just as if this were y or z over here, we would not be able to combine the 2 and the z. Same thing is true for these square roots. We cannot combine those square roots. So x is either 2 plus the square root of 2 or 2 minus the square root of 2. And again, we have two solutions to this. One of those is 2 plus the square root of 2. The other solution is 2 minus the square root of 2. So we still have those two solutions. Now for b, I'm going to get 0 on the right side by subtracting the x and subtracting the 9. So when we do that, we have x squared minus 2x, negative x minus the x, minus 6 is equal to 0. Now in this case, I'd always check factoring first, but there are no factors in negative 6 that add up to negative 2. You either have 1 and 6 or 2 and 3, and neither of those two pairs can be manipulated to get negative 2. So since a is 1 and b is even, I'm going to go ahead and complete the square on this one. So the first step is to clear that 6. I'm going to get that constant on the other side. And now to figure out what to add over here, I'm going to take this b value and take half of it. Half of 2 is 1, and 1 squared is 1. So I'm going to add 1 to both sides. Now, pay close attention. You just can't add 1 out of the blue here. Can't get it out of the blue because I used blue here out of, never mind. But you just can't add 1 to one side and not the other. You have to add the same thing to both sides. So, on the right side, I'm left with 7. And again, this right side trinomial will factor to a binomial squared, because this is now a perfect square. We completed that square. So what factors of 1 add up to negative 2? Negative 1 and negative 1. So therefore we'd have x minus 1 and x minus 1, or x minus 1 squared. So then x minus 1 is either equal to plus or minus the square root of 7. And to get the x by itself, we add 1 to both sides. 1 plus or minus square root of 7, and that's how we write that. And again, keep in mind there are two solutions to this. One of them is 1 plus the square root of 7. The other one is 1 minus the square root of 7. So there are your two solutions to this quadratic equation. And finally, the last two examples. The first one, once again, there are no factors of 7 that add up to negative 12. So since a is 1 and b is even, I'm going to complete the square. We have x squared minus 12x, and we move the 7 by subtracting it. Now we are going to complete the square by looking at this b value, which in this case is the negative 12. We're going to take half of it, which is 6, and then square that. So we're going to add 36 to both sides. So once again, on the left side, this is a perfect square trinomial, which will factor to the square of a binomial. And the factors of 36 that will add up to negative 12 are negative 6 and negative 6. So we have x minus 6 times x minus 6, or x minus 6 squared. And on the right side, we have negative 7 plus 36, which is 29. So then x minus 6 is either positive or negative square root of 29. And to get the x by itself, we simply add 6 to both sides. So we end up with 6 plus or minus the square root of 29. And again, keep in mind there are two solutions to that one. One of them is 6 plus the square root of 29. The other one is 6 minus square root of 29. Okay. And in D, again, I will check to see if it factors. I will subtract 10x from both sides. And once again, there are no factors of 12 that add up to negative 10, so this is not factorable. So I'm going to start completing the square by first moving the 12 by subtracting it. And to complete that square, I'm going to take half of 10, which is 5, and square it, so that's what I add to 25. So I'm going to add that 25 to both sides. And on the left side, that's going to factor to x minus 5 squared. And on the right side, I have 13, negative 12 plus 25. So then x minus 5 is either equal to positive square root of 13 or negative square root of 13. And finally, to get the x by itself, I add 5. So x is either equal to 5 plus the square root of 13 or 5 minus the square root of 13. Tomorrow, we'll take a look at our third method for solving these quadratic equations and just look to see how ugly completing the square can get when A is not 1 or B is odd. Again, I would only do this if A is 1 and B is even. Tomorrow we'll see just how ugly it can get if A is some number other than 1 or if B is odd. So that's something to look forward to tomorrow.